So there are some exceptions to the octet rule. The first ones we're going to talk about are things that have expanded octets. These are the atoms that when they form bonds, they end up with more than 8 valence electrons. So the octet rule says you can have 8 electrons, but these are going to have more than 8. So we say they're expanded octets. They're bigger than expected. Unlike many exceptions, you don't really have to memorize these. They're really pretty apparent. And if you follow the method for writing your Lewis structures, it's all going to work out for you. So let's see what some of them look like. Some of them are really obvious. Okay, SF6. Well, if I try to put 6 things around sulfur, obviously that's more than 8 electrons. But that is what happens. Okay, the 6 fluorines are attached to the sulfur. Okay, and when I give everybody 8, okay, although sulfur obviously has 12, okay, it's an expanded octet, but I'm going to give everybody else 8. I end up with, let's see, 6 plus 42, it has 48 valence electrons, and this structure, if you count it, has 48 valence electrons. So that's the structure of SF6. It's pretty easy. Similarly, PCl5, it's kind of obviously an expanded octet, because again, when I try to put 5 things around phosphorus, obviously it has more than 8, right? It has 10 electrons. So again, I just put all 5 around the phosphorus. Okay, and I'm going to find out that the electrons work out okay. It should have 40, and it does have 40. Okay, so these are called expanded octets. We're going to learn why this happens later. So for right now, you're going to see that it does happen. These are a little less obvious. Okay, so if I look at SF6, if I count my valence electrons, I've got 6 plus 4 times 7 is 28 equals 34 electrons. Okay, so I'm going to draw this. It's going to look like it's just like structures we've drawn already. Okay, but when I give everybody 8, I kind of have a problem, because when I count them up, I realize I only have 32 electrons. Well, when I had too many electrons here, it meant that I had done something wrong and needed a double or triple bond. When I have too few, it's really simple. I just need 2 more electrons. I add them as a pair to the central atom. So that's the structure for SF6. It has 34 electrons now, but you can see it's an expanded octet because sulfur has 10 electrons. XeF2, now this is the first time we've seen a covalent bond with a noble gas. Noble gases can form bonds, so don't be too surprised when you see one. There, 8 plus 14 is 22 electrons. So xenon's in the middle, right, the less electronegative element. Give everybody 8. And if you count, you've got 20 electrons. So again, if I had too many, I would need a double or triple bond, but I have too few. So all I have to do is add a pair somewhere on the central atom. So now xenon has 2 bonds and 3 lone pairs. So it's an expanded octet. So if you just follow the rules, you don't have to memorize them, it just kind of falls into place. So why don't you stop the video, right? And why don't you try to do RnF4? Okay, and then we'll come back and we'll do it together. So did you stop the tape? If not, can you stop the tape and try it? Because I'm going to go ahead and do it now, but you should try it yourself first. So I've got 8 plus 28 is 36 electrons. So Rn is in the middle, and I've got my 4 fluorines. I'm going to give everybody 8. But I've only got 32 electrons. So I need 4 more. So I'm going to put 2 pairs around the central atom. It doesn't matter where, as long as there is a pair. That's the structure for RnF4. So that's one set of exceptions that you don't really have to memorize.